Okay, I think this is take 6. Yeah, whatever. Okay. So I'm doing number 36, and it is right here. Two cylindrical swimming pools are being filled simultaneously at the same rate. The smaller pool has a radius of 5 meters, and the water level rises at a rate of 0.5 meters per minute. The larger pool has a radius of 8 meters, and we're looking to find how fast the water level is rising in the larger pool. At first, whenever you can, it will probably help you to draw a picture. If you're stuck, draw a picture. If you're not stuck, it'll probably still help you to draw a picture. So we have our two cylinders. The first one, the smaller one, is 5 meters. The bigger one is 8. Right. We're also given the rate of change, the change in height of the smaller cylinder, and that's growing at 0.5 meters per minute. And we're also told that they're being filled at the same rate, so I'm assuming it's the same source filling both of these at the same rate. We'll call this dV dt. And what we're looking for is how fast this water level is rising, and we'll call that dH dt. And actually, we're giving the dH dt of the smaller, we'll call dH dt of maybe, we'll call it like 8 or something like that. And we're actually giving the rate of change of the smaller one, and it's actually right here. And so we'll just label that dH dt 5 something. Okay, and so our relationship for cylinders is volume equals pi r squared times the height. Alright, and since both of these radii are static, like no matter how much water you put into the first one, no matter like what you do to it, aside from destroying it or building onto it, it'll always be 5. The radius will always be 5 meters. Same goes for the second one. It will always be 8. So what we can do is just plug in that 5. So V equals pi times 5 squared h. And now we just find the derivative. So we get dV dt equals pi 25 times dH dt. And once again, for the smaller cylinder, we're given the dH dt up here. Or well, in the problem. But it's 0.5. So we just plug that in. We get 25 times 0.5 equals dH dt. Alright, so dH dt equals 25 pi over 2. So this number up here equals 25 pi over 2. Alright, now that we've found dV dt, we can find this dH dt, which is what the problem asks us to find. So let me turn the page so I have to write really big. Alright, so we got our dV dt. It's equal to 25 pi over 2. And our radius of the bigger cylinder is 8 meters. So we got V, once again our relationship is V equals pi r squared times the height. And once again we just plug in the radius because it's constant and will not change in this problem no matter what. So V equals 64 pi h and find the derivative. So dV dt equals 64 pi dH dt, and once again we just found this value, the dV dt, and that's equal to 25 pi over 2. 25 pi over 2 equals 64 pi dh dt. And just solve for dh dt, and that's as easy as dividing. So 25 pi over 128 pi equals dh dt. And the pi's will cancel, and I don't think anything else goes away. So this is our answer. The change in height, or the change in time, of the biggest cylinder is equal to 25 over 128. Right? Yep. And that's our answer.